All right, so I decided to do a different approach on this lab here. Instead of kind of going back and forth to this, this is what we have. This is what we were talking about. This is where we were in our program or our lesson. And I was kind of drawing this out with PC8 and so on and so on and having all this. This is going to be kind of a mess. So I'm going to go ahead and close this out. And I'm going to bring up a different document here that I have created. And the question is, where is it? There it is. Okay, so as you can see here, it's going to be the same. It's going to be the same layout as far as our diagram we were looking at, or our lesson that we were looking at, which is right here. So PC1, 2 is going to be over here, obviously, in Network A. And PCB is going to be over here in PC8 is going to be over here in Network B. And, of course, we're going to have a router here. One of these interfaces is going to be in this network. One's going to be on this network. And we're going to kind of bring this a little bit farther up here by stretching this out. And we're going to zoom that in. And we'll just go ahead and shorten that up a little bit. So that's really how this is set up. We have PC1 and PC2 sitting right here on the same network. And PC8 is sitting over here. And in between here, we have a router. Now, as you can see, we have this interface in 192.168.1.10. which obviously the network number of 192.168.1 is identical to these two PCs, which means they're on the same network. And here's PC8. Now, I've given them specific MAC addresses so we could see this traffic as we're looking at it being sniffed. We're going to look at this traffic as a Wireshark. And we're going to be able to see this traffic. So there was no point in me actually putting the MAC addresses on here. It's because they're pretty straightforward. All right, now you can see up here, if it's not too small for you to see, it says PC1, here's PC2, and over here is PC8. So first we're going to verify that our IP addresses are correct and what our MAC addresses are. So pretty simple, 192.168.1.1. That's for PC1. You can see down here that we are labeled PC1. And look at our interesting MAC address. All ones, saying that, hey, we're PC1. So let's take a look at this one. (192.168.1.2), as you can see it over here. And look at our MAC address, all twos. Very easy, okay? Now let's go over here to PC8. And as you can see, 192.168.2.8 and all 8s. Take a look at our ARP table here. So you can see I don't have anything for the other PCs yet. So let's take a look at our traffic. And as you can see, we already got a bunch of stuff going out. So let's go ahead and change these options here. And I want to say host 192.168.1.2. I just want to look at that traffic going to 1.2. So we don't have to weed through all that traffic. Now I'm going to look at this ping command because I only want to do a count of 1. So let's go ahead and let's shrink this just a little bit. And let's ping 192.168.1.2. And who am I again? I am 1.1. So I'm coming from this PC over to here. I'm going to do a -N for count and say 1. So I did one ping. Now here's the information. Let's see if we can make this a little bit bigger here. So the information is a little bit bigger, so you guys can see it. So it makes it a little bit less manageable, so to speak. So let's kind of stretch this out a little bit. You can see they're kind of bleeding in together. And we're going to discuss exactly what we're looking at here in each one of these columns. I should be able to split this. Let me figure this out here. All right, well, I guess the length and the info are just going to have to be merged together, I guess. All right, so starting from left to right, we got a number. Now, this number pretty much tells us the packets as if they're going out. And obviously, I can change this by clicking this. And obviously, number 1 goes to the bottom, and number 16 goes to the top. I stopped the capture because we're going to start getting a bunch of Microsoft traffic and stuff like that. We don't want to see that. So I'm going to go back to the very first data that we captured that went out. Then we have time. Now, time, obviously, is pretty much going to match up if this time is doing it one by one. Obviously, it's going to catch. Don't worry about the time. Source. Now, this is important because this is saying where is the data being sourced from. Now, I can change this and notice that my numbers are now not in 100% order, which is nice. Okay? So now we know we can always go back to our original order of data that's leaving. So that's nice. So a source tells us who we source from. And we can put them in order, which is nice. Obviously, we can get all the ones that are sourced from here, all the ones that are sourced from this address, so on and so on. So now, we also have destination. And that's good to know as well. So we can sort by all these. And another one is protocol. And then the length. Now, the length, for some reason, I can't separate the length and the info in Wireshark. I even tried it on my PC, and I just couldn't do it. I don't know why it's attached like that. But nonetheless, we have the length of the data that's going out. How long is it? And, or the size, how big it is. And then we have this info. And some of this is helpful, and some of it's not, but most of the time, it's going to be pretty helpful for you. So we're going to go back and do this number by, we're going to do it by the numbers, which means we're going to do it as the first data that we captured went out when I did that ping. Now, let's take a look at this red marking here. Let's full size this. And this red marking is a TCP, and that's not what we're concerned with. We're concerned with that ping. Now, remember, the first thing I talked about was ARP, right? As the traffic is going out. And when did we discuss this? We were talking about basic communication, and we were talking about the ARP table. So, as we see in our Wireshark here, first thing we want to do is kind of shrink this down somewhat, or just bring this down here. Notice that the first message that went out when I tried to ping was a broadcast address. It was sourced by what MAC address? By me. I'm on PC1. It was sourced by me, and it was destined as a broadcast. Now, if we look at this information, this is nice that it gives us this information by telling us exactly what the source IP and the destination IP is. However, we really need to look at this data here, because this is what's going on. Now notice that this is an ARP message. It says Address Resolution Protocol. Now if we go up here and look at this first line that we're actually seeing, which is actually really number 2, but 192.168.1.2. This is the description now. This is the info. It says, who is 192.168.1.2? Notice it's a broadcast, and the protocol that we're using here is ARP. So here is our ARP information. Remember that encapsulation information that I told you about? Well, here we are. We're encapsulating this data with Ethernet information, which means that the real data here is the ARP request. This is the message that I'm trying to send out. This is the data that I'm trying to get to someone. I don't know who it is specifically, so I sent out a broadcast. So I'm going to encapsulate this data by putting this Ethernet information on top of it. What is this? Well, this is our source MAC address, and here's our destination MAC address. Well, doesn't that look familiar? What's a source address, a source MAC address, and a destination MAC address? What is that? That's right, our layer 2 information. So when that information goes out, it's going out with this first. No one's going to see the ARP information until they open up and remove the layer 2 information. And this is why we call it encapsulation. So the data will be at the bottom, and then we'll have all these layers on top of it. Well, this is the layer 2 layer. Now this is the frame. This is the entire frame that goes out. And what we do here is we take all the layer information and we're going to bundle it into this Ethernet frame. And here we go. Here's the frame. And this frame has a lot of information of all the stuff that's below us. And there you go. However, this is where we stop here, which is layer 2. As you can see, the source MAC address is myself, all ones. And the destination MAC is all Fs, meaning it's a broadcast. Now this is really nice to know, because as he sends this information out, the first thing he's trying to do is I'm trying to communicate with PC with the actual address of 192.168.1.2. This is wrong. I'm going to change this in a minute. 192.168.1.2. I'm trying to communicate with this. So the first thing I'm going to do is I'm going to look in my ARP table. Well, guess what? It's not there. Because remember, I must have the source IP and the destination IP for communication. I must have them both. So I use the ARP table to give me the MAC address for all the IP addresses that I'm trying to communicate with. What's going to happen now is, if I don't have it in my ARP table, what am I going to do? I'm going to send out a ARP request saying who is 192.168.1.2. I'm going to send it with a destination of all Fs, which for layer 2, that's a broadcast address. That comes into here. This switch says, oh, okay, I understand that. It's a broadcast. Let me send it out all switch ports, except the one I came in on. All the switch ports. So router 1's going to get it. He's going to open it up and say, well, you're asking about 192.168.1.2. So that's not me. I'm not worrying about it. This PC is going to open it up and says, oh, you're trying to find out who 192.168.1.2 is? Well, that's me. And then I'm going to send information back. I'm going to reply to your request. So let's find out the next information that happens with our Wireshark. So the next piece of information that happens after this one is done, notice that I get information that is sourced from PC2. How do we know this? Because it's source 2.2.2222. Remember, guys, anytime you're getting data that's being sourced or destined by the MAC address, that means we're just doing layer 2 communication, right? A lot of people don't know this. A lot of people get kind of confused when they start seeing this, like, what's going on? Why are these, what are these numbers? They're MAC addresses. And it's just layer 2 communication. So look at the information that's coming from 2.2.2. I'm sorry, coming from 192.168.1.2, coming from MAC address 2222. And it's coming back to me. And it's still an ARP message. Or ARP protocol, I should say. So let's go take a look at this. Notice that every time I click here, it changes my data below. So right now I'm on the second message. So let's take a look at this ARP. Notice this is an ARP reply. The original one was an ARP request. Now this one is an ARP reply. He's replying back. Now, if we go back to this one, to the request, look what it's saying. Here's what's in the ARP request. This person who sent it was 1.1.1.1. Now, isn't that nice to know who sent it? It is. Because now, when I need to go reply to this, I know who sent it, so now I can make sure that I send it back to 1111. I have the sender's IP address in there. That's nice to know as well. So I can send it back to the IP address and the MAC address. Because what will happen when he tries to send this information back and he doesn't have the IP address of the person who originally sent it? Or the MAC address of the person who originally sent it? He would have to do an ARP request. And if this information was never sent back and forth in this fashion, we would just constantly be sending ARP requests back and forth. So this also allows me, PC2, whoever I'm sending it to, which remember, we're sitting on PC1 now. We sent this information. We're looking at the request now. This allows whoever I'm sending this information to build their ARP table as well. Because when PC2 gets this information, he's going to say, well, I mean, while I'm at it, I might as well just put this entry in my ARP table. Might as well. Target MAC address, target IP address. And notice the zeros because we have no idea what those values are. So when a reply comes back, which this is now the reply we're looking at, let's see what he says. Sender MAC address is 2. Sender IP is 1.2. Now that's nice to know because now when this comes back to PC1, PC1 will now update its ARP table. That's the information it needs right there. Now remember the original packet or original frame that we sent out, it was a broadcast message. And let's look at the layer 2 information. Our destination from PC's perspective was a broadcast. But now when that